Hello, welcome to Chemistry 101 tutorials. If it's your first time joining me, please go down there and hit the subscribe button. Yes, I'm waiting for you to hit that subscribe button. I'm not going to say anything. I will wait until you hit that subscribe button. Okay, thank you very much for subscribing in my channel. Alright, so now I've prepared today 3 questions. So without any further waste of time, let's start with the first question. How many moles of calcium are in 3.5 mole of calcium carbonate? Really easy question. And a lot of people are always confused. And here I'm going to show you in one single step. Okay. Alright, so yeah, you are told that is 3.5 moles of calcium carbonate. So one thing that you have to really bear in mind is that here in this compound, calcium carbonate, there is only one atom of calcium. Okay, so that means in 1 mole of calcium carbonate we have only 1 mole of calcium, and we are going to use that as our conversion factor. Okay, so if for example it was carbon, it was still going to be the same, but if it was oxygen, it was going to be a different case. But in this case we are asked only for calcium, so I'm going to use that conversion factor. It's multiplied by 1 mole of calcium over 1 mole of calcium carbonate, and the answer is 3.5 moles of calcium. Okay, yeah, that's easy. That's the final answer. Yeah, so if it was carbon, it was gonna be the same answer, and if it was oxygen, it was gonna be a different answer, because you're gonna have 3 moles of oxygen here over 1 mole of calcium carbonate. So you just have to look at your given compound. Okay, all right. So yeah, next time you ask this question, it will only take less than 1 minute to answer it. Let's go to the next question. Okay, so the next question is little bit yeah, not a little bit challenging, but it's okay. Calculate the number of grams of nitrogen gas which are needed to react fully with 1.5 moles of hydrogen gas to produce ammonia. Okay, so in this case, before you can do anything, please first write a chemical equation. Okay, so in this case you are told that N2 will react with H2 to produce ammonia. Okay, this is a commercial Haber-Bosch equation, not equation, yeah, it's a Haber-Bosch reaction. It's a commercial Haber-Bosch reaction for producing ammonia. Okay, so and after writing the chemical equation, you have to make sure that the equation is balanced. A lot of students don't know how to balance a chemical equation, but we're gonna do this in 1 or 2 minutes. Okay, so here you have 2 nitrogen, 2 hydrogens. Let me write that down. 2, 2. Here you have got 1 nitrogen, so you have 1, and here you have 3 hydrogens. Okay, so now so the nitrogens are not balanced here, and also the hydrogens are not balanced. So maybe I can start first by balancing the nitrogen. So I can do this by simply putting a 2 there, and immediately when you put something, you or any number, you need to again recheck your equation. Okay, so don't immediately go and try to balance hydrogen. So first check again if it's still balanced. So we have 2 in this case, and then hydrogens here we have 2, but here we have 3. okay? So it's gonna be 2 times 3, so that means here now we have 6, okay? So what can I do here? So that means I have to balance on this side. So here that means I'm going to put 3, okay? Yeah, now it's balanced. So 6, 2 times 3, 6, 2 nitrogen and 2 nitrogen, okay? Yes, we got that one right. So we'll delete this. So now our equation is balanced. And now what is the question? We have to calculate the number of grams of nitrogen which are needed to react fully with 1.5 mole of ammonia, not of ammonia, of hydrogen to produce ammonia. So in this case you have 1.5 moles of H2. So and we need to now calculate for nitrogen. So that means we will have first, like I said, you need to make sure the equation is balanced. So now you will use the mole ratio in order to calculate the number of moles of nitrogen before you calculate the grams, okay? So the mole ratio between these, you take it from the chemical equation. So here is the same as we have 1. So that means we have got 1 mole of nitrogen divided by 3 moles of hydrogen. So this is mole ratio, then multiply by, so in this case this and that will cancel out. So that means now you have the number of moles of nitrogen, but the question needs grams. So in this case then we'll multiply with the molar mass of nitrogen, which is 28 grams of nitrogen over 1 mole of nitrogen, okay? So this is the molar mass. I already explained this expression on the previous video. I will put a link also on the description, okay? So then 1 mole of nitrogen cancel out with 1 mole of nitrogen, and your answer will be 28 grams of N2. Yeah, that's it, done. Yeah, really easy. Okay, so let's go to the last question real quick. So the last question, I'm gonna put it here. So try to create space there. Okay, alright, we'll try to put it here. So I already put my balance equation here because we will need it. So the equation here asks us to calculate the number of moles of nitrogen and hydrogen which are needed to produce 1.5 mole of ammonia. So in this case we need to calculate the number of reactants, all of them, that will react together to produce 1.5 moles of ammonia. So in this case you will have 1.5 moles of ammonia multiplied by, so you are still going to use the same thing, the mole ratio. So let's start with the nitrogen. So that means you will have 1 mole of N2 divided by, yeah, that is the mole ratio of ammonia. So 2 moles of ammonia, and the mole cancel out, and your answer will be, in this case your answer will be 0.75 moles of nitrogen. So I will let you do the other one for hydrogen. So it's the same steps. So here mole ratio, and then yeah, you will get your answer. So in this case you will have 3 here instead of 1 because of the coefficient there in the chemical reaction. Okay, so yeah, that's it. That's the end of the video today. You will solve that one alone, and maybe you can put the answer also on the comment section, and also complete your homework, okay? In every tutorial I will upload a homework. Okay, all right, bye bye, and I wish you more success.